Swayam Prabha. Digital India. Educated India.
All right. So, out of the 4 areas that we described, I'm deep diving into cloud security. Again, like we said, there are the landscape. When you look at the threat landscape, there are targeted attacks happening across multiple threat vectors that are available, but still cloud is an imperative, or businesses wants to adopt cloud mainly because there is a lot of business value, than it's not driven by technology or technical merit alone. Because what's the let me ask you all, what's the good and bad about cloud? Why do we recommend people to use cloud? So the answer was resources can be shared. Right. So, one of the stuff, or one of the key characteristics of cloud is highly virtualized and highly automated. So, when I say virtualized, you can have a physical machine like a 4 CPU machine can be sliced and diced into multiple parts and given away to different people. So, you are making full utilization of that resource. So, from a business perspective, that is business value, you are deriving more out of the resources. What else is the key criteria for cloud? Access from anywhere, and in fact, how many of you know what is the meaning of cloud and cloud computing? What does it stand for? It stands for internet. So, you are able to connect or get compute over the internet. The architects typically use a cloud to represent the internet with a cloud. So, that is how the the name the cloud computing came. So, any computing that you can get over the internet becomes cloud computing, right. So, going further, what other business benefits? So, the important business benefit here is that you are able to get resources on demand, right, because it's like on the internet. So, just like the way you don't have to go to the railway station to buy the tickets now, you can get the railway tickets online, you can get a server, a storage, a network, everything over the network. So, you have the different patterns of infrastructure as a service. When you are getting infrastructure, you have the patterns of platform when you are getting the middleware or the software applications. Then you have software as a service. So, the main reason why businesses are interested in this is because they have the capability to get what they want over the network. And imagine the World Cup is going on now, right, the football World Cup is going on. So, imagine a FIFA website, if they want to have order like 100,000 servers to support the multiple million hits that they are getting to the website. What will they do with all those servers once the FIFA World Cup is over, right. So, here is where cloud comes in, and for the business it is like pay as you go model. So, that is where the capability of cloud, where you actually pay for how many servers you need, and after the event you can return it to the pool. So, it is very elastic in nature. So, these are the high 4 or 5 key attributes of cloud, which is becoming very interesting for customers. And when we talk about customers, these are enterprises who are across multiple spectrum, right. You have startups, it will be like couple of guys sitting in a garage in Koramangala building the next big startup application, right. So, they would not want to invest in a new set of infrastructure like a server which might cost them several $100,000. Instead, they would go to the cloud and get an infrastructure or a server where they will run that. So, one of the pattern you will see is people developing applications on the cloud. These are called cloud native applications. They are starting just on the cloud, right. Then we have customers who have already lot of infrastructure in their data center. So, they are trying to see how to migrate some of this to cloud, and there are few others who have something here and something there on the cloud. So, they want to make sure that it is modernized and it can use like for example, the airline industry or some of the telco industry, they are not going to overnight throw or get rid of their infrastructure that they already have, right. So, there are like these three patterns, building natively, migrating, modernizing. There are like these three patterns that you see with cloud, and in all of that their core requirement is that we need a trusted cloud platform. So, what do you mean by trusted cloud platform? So, if you look at traditionally how do you do data security is, how many of you heard of firewalls or used firewalls? So, what does a firewall do? It good answers. So, it actually acts like a gatekeeper, right. It lets the good traffic in and blocks the bad guys out of the. So, the traditional way that we have been using security has been like you create what we call like the defense in depth model, just like the way the kings in the olden days used to protect their crown jewels. You create multiple levels of defense, and firewalls is one of the defense mechanism, and then you put the crown jewels behind those firewalls, right. So, the attacker, even if he breaks through one wall, he has to break through multiple of them to get to your data. Now, when we switch to cloud, they lack this, the concept is reversed. Actually, you are actually putting what is your workload or your application on the cloud, and then you need to see how do I protect this. Earlier days, I exactly know where is your server. It is in that server room, in that lab, and in this place. But in cloud, you don't know where it is running. It is all in the internet out there. So, you will have to bring the security services also to the cloud. So, if your application is moving to cloud, your security also should move to the cloud. And there are two ways that you can do it. One is you have security services that are built in the cloud, and then you can bring in what I am calling as security in the cloud. So, these are just like any other service that you take from cloud, you have security available as a service to secure that application, and then you have security which can be added on top of that to secure your workload, right, which are like add-ons. You can bring additional. So, some things you will get from the cloud platform itself. And when you talk about cloud security, there are, apart from providing a trusted cloud platform, there are two other attributes. One is again traditionally we would secure that perimeters, and we would secure the application, and you are done with that, because nobody else is going to touch that environment and all of that. And traditionally again, if you use one application, call it some CRM application or some application that you are using, if you deliver that once a version 1.1 or something, the version 2 would take like anywhere from 8 months, 6 months to 10 to 12 months for the next version of that software to come out. So, when you do the next release, then you go and look and harden that. But with cloud, how many of you heard of this term called DevOps? So, it is actually development and operations coming together. So, the previous days what used to happen is somebody used to develop, throw it off to somebody else, and that somebody would run that application and serve the customers. Now, what is happening is, in a as a service model, you have development and operations together. And how many times do you think Facebook or Instagram is updating their code? Is it once in 6 months, once in 8 months? Pretty often. How often? Every day. That's right. So code is being getting changed almost every day. There are like enterprises who are making changes like 2000 changes in a week. So for the bad guy, the threat landscape starts there. You have to make you have to control, or you have to monitor the 2000 odd, I am saying 2000 code pushes that happen. There will be more of the delta or the code change that happens. So if a bad code or a non-secure code is written, that's all threat landscape. So when you talk about cloud, so cloud enables this DevOps model where you can continuously push new code into the production. So security also becomes something that you have to do continuously. It's not that you one time you do this and you are secure and you forget about it. And the last but not the least, all of the customers are having their data protected. So that is what we are calling the hyper protection for data. So let us deep dive into what is in the cloud native application. So how many of you are familiar with microservices or come across this term? How many of you are familiar with containers? Heard of containers? Okay. I believe all of you are familiar with virtual machines. Yes. Okay. So if virtual machines creates one copy of each of the operating system all the way from the OS stack upwards, containers is a even more lighter way to ship your software components. So it can pack all the libraries into a small, just like the way you see the containers on truck, right? So the objective is the same container can move on truck, or if you put it on a railway track, it can be transported from one place to other, or you can ship it by ship or air, all of that. So the same container, the contents inside doesn't change, but you can run it on any platform, right? So that's the beauty that software world is also adopting. So if you are not familiar with containers, go read up. That's going to change the industry and how software applications are being developed and deployed and operated, right? You can look at what is Docker and what is Kubernetes. Docker becomes a management framework for these containers, and Kubernetes is a cluster management of these containers. Imagine like 100,000 containers out there, right? How do you manage all of these things? So the beauty of containers and the relevance here is when you talk about a cloud native programming model, microservices is a model that we are adopting to implement cloud based applications. So the cloud native programming model is something like splitting your application into a set of microservices and then putting those microservices together to do the job. So that's how the solution looks like. So when you design microservices, it is mostly what you call do just one thing and one thing right, just like the principle of Unix, right? So that is how these services are being built. And if you look at the reference architecture here, so you have a cloud application which is formed of microservices, and they are using set of data services, the runtime services from the cloud. So I talked about multiple of those layers, the infrastructure services, and then on the left hand side you have the public network, the users that are leveraging that service, and on the right hand side we are connecting back to the systems of records, right? Across all of this you have multiple, or in each of these you have multiple attack vectors. So how do you determine that this person is coming from the right network, using the right device and all of that, right? So we will see most of it getting covered during the course of the day on the left hand side. I am going to focus more on the central part. where the key concerns are around data security. How do you secure data at rest? How do you secure end to end secure channel from the place the user is starting the interaction from their browser all the way to the application endpoint or to the microservice, right? How do you have a clear SSL, TLS or HTTPS connection? And I will talk about more about data security in the next slide. And then how do you, so there could be bugs and misconfiguration of the application. So it is like, you know, we have a strong door, and but if we leave the window open, people could get your data through the application. So the application security is another important aspect of security. Then when it comes to cloud, it is basically again you are out there in the open, and then people know these are IPs that are belonging to a particular cloud, and they will be trying to attack you through the network, through the application layer, through the data layer. So there is, as you can see, the landscape is broad, and there could be insider threats. So what are insider threats? Right. So some of the add to that answer is some of the people who develop and operate this, there could be bad guys in that. So they could add bad code there so that they can exploit it later, or they could be having privileged access to certain systems. So they can go and find out, okay, this is a database of all the patients in a particular hospital. So recently Vajpayee was admitted into the hospital, and somebody wants to go and if he is a database administrator of that hospital, he could try to go look into those details so that he can share some information with media and make some quick money, right? So these are all insider threats, but that is privileged data, and only privileged users should be able to access. So there is attack surface all across. So our point of view on how do you control all of these is, firstly we start with a trusted platform, right? So you have to build trust from the infrastructure level all the way up, infrastructure, OS, the application, the services, and the service that you are building on top of it. So all of that has to be secure. So that is where we calling it a secure platform. Then we talk about managing identity and access, which are two things. So if you go back to the previous slide, there are two sets of application users. One is a application user and other is a privileged user, like I mentioned, who are users of the cloud itself, right? There are developers and there are administrators who are developing and deploying the cloud, deploying to the cloud. And then you have people who are accessing those applications. So those are the app users, and in the new terminology it could be also other applications that are accessing this APIs of this applications, right. So you have to manage two sets of users, one is the cloud users and other is the application users. Secondly, you have to secure your apps, like we said, the app should be free of vulnerabilities. The code has to be statically checked, dynamically checked, and all of that stuff. And you also have to do what we call protect data, which is protecting data at rest, data in transit, and we are also introducing something called data in use. I will come to details of each of these. Apart from these, the core concern is I need visibility into my servers. Like in the traditional days, if I need to see what is running in my server, where is my server, is there power backup for that server, all of that is I can just go to the lab, see that my server is there, nobody is touching it, all of that. But in cloud, you do not get that visibility unless we build that visibility into the system. So people need visibility for your cloud resources. It is not just the infrastructure part, it is also the services part. You need visibility, who is using this API, right? All of that you need visibility. So, putting that in context, again going back to my initial picture where I told there are services in the cloud and there are services that you can add on to cloud. So, I am going to give you reference on what are some of the typical services that you will find in the cloud, and these are references from the IBM cloud. How many of you have tried Bluemix or IBM cloud before? Okay. So, I will show you some of the links where you can go set up your free trial and start leveraging IBM cloud. So, when we talk about identity and access, there are two parts, the managing the cloud users and managing the application users. So, managing the cloud users, you have the cloud IAM, which is the cloud identity and access management, which is built into the cloud itself. So, you go just like the way you register for an email ID, you can go register for a cloud ID, you can create your account, you can bring your other developers into cloud, you can give them roles, access to different cloud resources, because these are going to be again built in a pay as you go model. So, if you use more, you will be billed more, right. So, you can use your credit card to set up the account, and so that entire thing is taken care by the cloud IAM. Now, when you build a systems of engagement application, let us say a marathon is happening for the next 2 weeks and you want to build an application where people can log in with their Facebook IDs or with their Google IDs or things like that. So, you want to build that application fast, you are going to select a runtime, right. You will select a Java or Node.js, a Python, a PHP, whatever it is. You select the runtime, you write the code, you publish it to the application, but each time you do not want to write a lot of code to integrate with Facebook or to integrate with LinkedIn or to integrate with Google, etc. So, what IBM gives you is a service in the cloud, which is App ID, what you see there, App ID, which can actually take care of authenticating and providing authentication and authorization for the social based logins, or it could be login for enterprise customers. Enterprise customers would be using something like LDAP, directory where all the users are listed. So, you can integrate with that or with gateways, identity gateways, which are, how many of you heard of the SAML, SAML? So, please do look up SAML. SAML is a security access markup language based interaction for authenticating the users, and again SAML is getting old and the cloud based standard is called OIDC, or if you have heard of OAuth, OIDC is the identity layer built on top of OAuth. So, all Facebook, Google, everybody becomes what you call as open ID providers. So, you can bring your own identity to cloud, right, or to the application. So, App ID is one such application that will give you capability. So, you move few sliders and say create an instance of App ID and say tie this App ID instance to your application, and you can select I want Facebook login and write a couple of lines of code, and your application can now use Facebook or social login as a way to authenticate users. The second part is securing the applications. Again, like I said, it has become more about what you call continuous security. Like each time a new code is run, when it is pulled off the GitHub, there has to be a scan done for the code to make sure that it is good code. There are no vulnerabilities like people can take advantage of cross-site scripting or SQL injection, all of that. You can also look up what is called OWASP. You are familiar with that? So, the top 10 vulnerabilities. Yep. So, all of that gets caught at this stage, right, securing the application, right. And then once you deploy, you can also run the pen testing and the dynamic testing to make sure that there are no vulnerabilities in your application. And the third part is protecting data. So, for that there are three sets of things. One is we talked about protecting data at rest. So, how do you do protection of data at rest? So, it is by encrypting the data, so that somebody gets to your data, they will find only junk. So, what is encryption? Lot of those stuff will be covered in the later sessions, last session. So, the idea is you do not leave clear text in the cloud. So, basically clear text plus a key, and you mangle it or jumble it together, you encrypt it and then get to a encrypted data. So, key management is important, because if you have the key, you have the data secure. So, it is not about securing the entire data, you just have to make sure that your key is secure. So, you need a facility where I can create key, I can generate the key and keep it secure in one place. So, you have a service for that, which is the key protect or a key management service. And the second thing is where do you keep these keys? So, you need if you put it in software, people can take it out. So, there are devices called HSM. Familiar with HSM? It is a hardware security module. So, the key never leaves that hardware. If somebody tries to open up that hardware, that will be rendered useless. So, the key never leaves that, and only privileged people who have access to that APIs can call the APIs and get the keys. So, BYOK, just like you have bring your own identity, you have in the data side, you have bring your own data encryption keys, so that you are in control of the data. Even if your data is in the cloud, it is encrypted with the key that you are holding, right. The third part, the second part was, first part was data at rest, second part was data in transit. How do you protect data in transit? By encrypting. How do you do encryption for data in end-to-end encryption? What are the other things that you would need? So, have you gone to some websites and checked out this? Have you seen this green lock? How is SSL achieved? Right, it is achieved with digital certificates. So, do you know that most of the time the outages or things go down or is not accessible because a certificate expired. So, certificate is issued by a certificate authority, and that has got limited life, 90 days, 1 year, 3 year. So, somebody has to keep monitoring how many certificates are in use and when are they expiring. Before they expire, they have to get a new certificate and update that and all of that, right. So, for that you have a service called certificate manager in the cloud. So, you can put all your certificates in one place, you can get notified on expiry and take all of that action and all of that. Apart from which you also have we talked about data in rest, data in transit, and the third one data in use, right. Data in use, the key capability is like, imagine if there is a privileged user and you are running a container, the code is running and it is in the memory. So, he could take a core dump of that running application and read credit card numbers or read information out. So, how do you protect those threats? So, we need a capability where even inside the memory the data is encrypted. So, we have softwares like the IBM C platform, the mainframes as it used to be called in the olden days, the IBM C, as well as Intel has got a platform called Intel SGX. So, they have the capability, even if your running application is the core of that, you won't be able to take useful information outside of it. Okay. So, we cover 3 areas, right, data at rest, data in transit and data in use, and then the last thing is about monitoring the data part, which is activity tracker, and is another service which is in the cloud, where it will tell you what are the APIs from the cloud that has been called by each of the cloud users. And then you also have we are actually built a security dashboard which is called a security advisor, which will tell you all the vulnerabilities in your application. Like it will tell you, you have so many containers, these containers have some packages which are out of date. So, you have to go and fix those containers. It is very similar to VMs, right, or it will tell you that there are so many certificates out there, you have to fix those certificates that are expiring in the next 10 days, 30 days, all of that information will be given as a dashboard. So, these are the core set of services that you will see in the cloud platform itself, apart from the many other services that will. So, as a developer you can use security services just like the way you use infrastructure or any other runtime services. So, this is a overall view of the architecture in terms of starting with governance all the way down to the physical security, and to go through each of these blocks it might take separate days for that. So, let me at this point quickly switch to some demo. So, you have a question? Yeah. Okay. So, the question is what are the parameters that are required when providing the validity period, right? So, there are different certificates that are issued, SSL certificate that are issued by different certificate authorities. So, there are only very few what we call as the root CAs or the root certificate authority, and then you have something called intermediate certificate authority. So, the root CA signs a certificate and gives the intermediate CAs capability to issue certificate on their behalf, right, and you could request for a certificate from any of these CAs, and depending on the tier at which you ask for the certificate, the cost and the duration would also vary. Now, there is also a movement called Let's Encrypt, let'sencrypt.org. The idea is let us make all the security, all the applications on the internet secure by making them, all of them use certificates. So, these are Let's Encrypt issues you free certificates for 90 days, right. So, the duration everything changes, but you can actually the first step that happens when you request for a certificate is what you do create something called a CSR, which is a certificate signing request. So, you can also create your own what you call self signed certificate. So, you are the CA for that. So, the commands that you can use is like there is a open SSL tool, and you can use and create your own open SSL based self signed certificate, which are probably does not expire at all, like 25 years or all of that. But the idea is, given we are pushing code and pushing new features every day, it is, and the cloud could also be used for by the bad guys. Like I know there is a AES encryption out there which is pretty difficult to crack, but the bad guy can also use cloud to run algorithms to crack this secure component, right. So, let us say it takes like 3 months for somebody to crack that environment. So, maybe he is on the 80th day, that is when you will change the certificate, right. So, you overcome that threat by continuously like changing the certificate, so that even the powerful computer would take more than 90 days. So, that is why the banks and other internet providers ask you to keep changing your password every 60 days, 90 days, because there could be some hacker running the algorithms to crack your password, and he might have eliminated 90% of the other password guesses, and you should be close to the last 20%. So, when you change it, you are protected. The Let's Encrypt actually recommends like 90 days, and then we should have a provision to do automated renewal without any the service should not go down, service should be still accessible, and cloud has a capability to do that, right. You do not lose the service, at the same time you can keep changing the certificates. We do not recommend using certificates that do not expire, right. So, for those of you who are not familiar with cloud, so if you search for IBM cloud, this is the URL where you can go and register for your cloud account. You can create a free account, just search for IBM and cloud, it will take you to cloud console.bluemix.net. So, in my case I am having an enterprise account. So, I told about two sets of users, right, user authentication. One is the cloud users. So, now I am logging in as a cloud user, right. So, it understands that my ID is an IBM ID. So, it is going to redirect me to, so if it is like I am logging into American Express my ID is Shrek at American Express, it will take me to American Express's identity system to authenticate me. But in your case you can create an ID just like with your Gmail ID. So, you just type the ID and password there itself, right. So, what is this step called? So, these are again features of identity and access management systems, which is called multi-factor authentication. Moish, we are doing identity and access as well, covering identity? No.
That gets covered later.
Okay.
That's next week.
So, it knows that I am accessing this cloud from a new device, a new client device, which is this browser, which it does not know. So, it is trying to validate the user. So, that is a multi-factor authentication or a two-factor authentication that is typically advised. You can do this for your Google IDs or your Yahoo ID and all of that. So, you have a fairly large catalog here, which talks about all of these. So, this is a cloud which gives you infrastructure services, compute, storage, network, security, containers, VMware, all of that, and it gives you platform services. You can create runtimes, APIs, application services, Cloud Foundry apps, all of that things. Plus you have security. So, what I talked about till now was only the services that are available in the security tab. So, as you can see, there is a rich catalog of all the services that are available. So, what I talked about just now is just the security tag. So, we talked about app ID, we talked about certificate manager, we talked about key protect, which is where you keep the keys, encryption keys, and activity tracker gives you the logs of what has been the usage, right. Yeah. So, the cloud IAM that we talked about, you can go here and see that you can manage the security here, who has access to what, and all of that can be controlled here. All right. Now, apart from this, there is also the network security components, which you see. There are tools like the web application firewall, which is the cloud internet services, which actually blocks the denial of service attacks and or the DDoS stuff. So, that is another part that I missed to talk about. So, what you can do is, all it takes is, like if you go to the security part, you can actually create a certificate manager, like let us say so, it is like again a self service model. You need a service, you can click and create that service. Some of these security services are free for you to try out, and if you go through this part while that is coming up, you will also see the there you go, the certificate manager is up. So, you can import your certificate and that will be available to you, and unfortunately I was planning to show the demo from my laptop, but once you create or order a certificate, you get the certificate, you can upload, and you can get notified on the certificate usage, and there are APIs using which you can get the certificate and the private key. So, you have to deploy this to where the SSL termination happens in the microservice, where that is, so that there is a secure connection between that service and the browser, right. So, that it shows the certificate. Apart from these, give it a second for so, this also has a container as a service. So, you can build your container on your laptop, and then you can ship it to the cloud and run it on the cloud, right. So, you can play with Kubernetes based container services, which are the clusters of that is showed here, and yeah, I have not created the app ID yet, but I wanted to show you the security advisor also. So, this is my product, which we are working on from here in India as well, where you can actually go and see the security advisor dashboard, where it tells you, how many containers you have, how many of them have vulnerabilities, how many certificates are there, how many of them are expiring. So, let me switch to so essentially you would see all the things in one place. There are 5 certificates that are already expired, and you can see the details of that, expiring in 10 days, all such information. And similarly, there is an add-on that we have built where you could actually check is there any bad guy communicating to my machines? So, those are suspicious clients, or is any of my IP communicating to bad IPs? All of that can be done by adding this security analytics add-on. And this is the piece around vulnerabilities, like how many containers you have, what vulnerabilities, package vulnerabilities or configuration vulnerabilities that they have. So, that is all I wanted to share. Any questions, queries? All right. So, there is reference material around, what are the stuff that you can use. You can search for Cloud Architecture Center and you can get some of this information. So, with that I will stop. Thank you for the listening and the questions. You would have more deep dive in more of the topics that we talked about. If no other questions, we will end this session. Thank you.